So yeah, my name is Tamil. With respect to the contribution to the Humane Society, it basically boils down to, as most SREs, I kind of don't like people, but I love animals. So I figured, it's just a no-brainer. And with that, this is an interesting experiment. This will be my first online conference. So thank you everyone for joining and attending. Let's get started. First of all, these slides, which I hope you're all capable of seeing now. So hi. Most SRE conferences tend to focus on lessons learned, do's, don'ts, mostly the do's really, right? We talk about tools, we talk about techniques, we talk about the various methodologies we employ to keep systems up and running. But it's actually not what I want to do today. What I want to do today is actually focus on things that we do tend to do, but should not be doing because, well, they screw us over and cause us to lose availability. So right out the gate, the story is an old one. You've all been there, right? It's roughly 3 o'clock in the morning, you're asleep, the cat is happy, and next thing you know, you get a notification from, say, PagerDuty. Now that might be a phone call, it might be a text message, it doesn't really matter. The point is you have to wake up and respond. And a couple of minutes later, as you dig through logs and try to figure out what's going on, you end up realizing that, well, looks like that's it for your sleep tonight, and now your life kind of sucks because you're on call and you have to take care of business, which obviously tends to make you very unhappy. So a very, very, very short interlude on why it is I feel I'm qualified to talk about this. So as was said, I've been around the block. I've been in the software industry for about 20 years. Recently, I joined Strigo, which is a startup. Before that, I worked for Wix for about 5 years and WeWork for a couple of years. So over the last course of 20 years or so, I've both built and maintained and operated many, many, many production systems, which doesn't really mean much, except that I've seen lots of things that we tend as an industry to get wrong. I've seen a lot of process in place that causes more harm than good. I've seen a lot of bad practices being employed. And this is where I try to sort of look back through the 20 years of production system use and try to arrive at 5 kind of canonical anti-patterns, organizational anti-patterns, engineering anti-patterns, things we do that we should definitely not be doing as an industry. And therefore, these are the 5 nines of availability, 5 anti-patterns that if you employ will cause loss of availability in your system. Starting with number 1, do not make it impossible to break. One of the most common recurring themes that I've found is a sort of a panic reaction to problems in production. And a very, very common and sad tale is when you have an engineer that pushes a change into production and that change breaks. It breaks the system, it breaks horribly, right? People get up in the middle of the night, they sort the problem out, then you have a post-mortem. Now, what often happens right after that is that some well-meaning soul says, well, this is the result of human error, so what we should do is we should try to negate or mitigate human error. And one of the most common ways of doing that is, for instance, requiring reviewers to review every piece of code before it goes into the master branch and made available for deployment. This is a very, very, very common theme. The problem with that sort of approach is that it tries to deal with one of the fundamental aspects of what we do, which is it tries to avert human error. And human error is inevitable. People are going to make mistakes. So if they're not going to make a mistake in checking in the code, they're going to make a mistake in configuring the system or in entering some piece of information into a third-party system or any number of ways in which you can bork your production environment. And trying to avert human error is an exercise in futility, because you can't. People are going to make mistakes by definition. More importantly, though, the process that really started off with a well-intentioned idea, right? If you have a piece of code, you have a change that goes into the master branch, you want to have more pairs of eyes on it. As Linus once said, more eyes make bugs shallow, right? So ideally, you want the code to be reviewed, the change to be reviewed by as many people as possible. The problem with that is, to start with, it won't solve your problem. Just having people review the code isn't going to really mitigate the human element in the equation. People are still going to make mistakes. And moreover, a lot of the mistakes are kind of subtle and oftentimes will not be caught in a review. Whatever process you have in place to make human error less likely to happen is not in and of itself a bad thing, but it's not going to solve the problem fundamentally. What you want to focus on is, you want to focus on recovery. You want to focus on, once a mistake is made, how do you make sure you recover from it as cheaply as possible? The really bad issue here is that adding more process not only will not solve your problem, but it will royally screw you over at 3 o'clock at night when your system is down for the count. Because at 3 o'clock in the morning, the only person that is actively interacting with your system from a staff perspective is your on-call engineer, if you have one, right? It's 3 a.m., they're going to wake up, they're going to deal with it. They're not going to like it, but it's their job. Everyone else is asleep. Everyone else is not available to help. What this means is that if your on-call engineer is left scratching their head at 3 o'clock in the morning trying to figure out how to get a really urgent fix into production, and then they have to wait for other people to either wake up or actually make the call and wake other people up, you are now organizationally just sitting there and waiting while your system is unavailable. So the process that you put in place to avert human error is the same one that is hampering your ability to fix whatever it is that's wrong with your system. Now, what should you do about it? Well, trivially, you want to avoid having a necessary process, right? Ideally, you want to not have the process that is hampering you, especially if it doesn't solve anything. But categorically, there are certain situations in which you want that process anyway, or you can't avoid it. For instance, if regulation requires, or you're working in some kind of SOX-based organization that requires that sort of process, then what you have to do, it is incumbent upon you as engineers in the organization to provide means of circumventing those barriers. So if you require code reviews for every change that goes into master, what you should do is you should have a very, very easily accessible way of doing it anyway, of forcing the issue, of leaving your on-call engineer with the ability to first push the fix to production, and then later explain why they circumvented the process. And if you're worried about it, then audit it, right? Log it. Make sure you have a run book, you record everything, but don't create a situation where the people who are under the most pressure are the ones that have to wait for others. So that is one very common mistake. The dual of that, which is our second Nein, is do not put artificial barriers in place. The previous example I gave was in reaction to something that had happened. But organizations also tend to put a lot of proactive barriers in order to, once again, avert the chance of something bad happening in production. One very common example of this would be if, for instance, you are not allowed access to your production database, for instance, or you're not allowed SSH access to your production servers, right? These are very, very common barriers that are put in place, and they're very bad for you. Now, there are generally only two reasons why organizations put these kind of barriers in place. One is they have to. From a regulatory or compliance perspective, you have to have some sort of access control in place, and that is not negotiable. A canonical example of this would be if you're dealing with credit card information. typically the system storing that information and manipulating it is required to comply with PCI DSS. Now, what often happens, and a very, very common mistake organizations make, is because putting those barriers in place, because having those access controls in place is fundamentally a strategic move, and it is expensive to implement, and it is expensive and difficult to maintain over time. What they end up doing a lot of the time is they take the easy way out and apply whatever restrictions are decided upon. These restrictions tend to be applied organization-wide. Once you have one subsystem that requires these types of access controls, a lot of the times organizations from a management perspective just go, well, okay, we've already made this investment. It'll be easier to just apply this restriction everywhere and be done with it. Now, this, once again, will cause loss of availability, because this means that at 3 o'clock in the morning, your on-call engineer typically will need access to your production systems. They'll need access to the production database in order to solve whatever problem is, woke them up to begin with. So if you have to do this from a regulatory standpoint, then first of all, you want to limit the surface area of these restrictions to as small surface area as possible. So if you are dealing with credit cards and you have a subsystem that deals with credit cards, apply PCI DSS restrictions and compliance checks and audits just to that subsystem. Wrap it up in a nice, VPN, DMZ, whatever it is that works for you. Have a bunch of servers that you have to tunnel through, whatever it is you need to do, but only do that to the smallest part of your system that you can. Furthermore, it is still incumbent upon you to provide a way of circumventing those access controls when things go bad, when things go bump in the night. Now, again, you need to have those access controls in place. They need to be monitored. You need to log when people circumvent these restrictions or are assigned special privileges temporarily. You need to have that logging in place, because you will be audited for it sooner or later. But you still should allow very rapid access to that data that doesn't require shall we say, a synchronization point, that doesn't require you to wait for your boss to approve it. The other reason is not a good one. Regulatory concerns are something you can't argue with, right? That's a business value. That's something that you have to do. But the other reason, and the more common one in my experience, is lack of trust. Most companies I've worked at, I've worked for, I've worked with, or that I have observed, generally put these restrictions in place because they don't trust their engineers to muck about with production servers and production data. It's too risky, they say. So to that I answer, if you don't trust your engineers to operate the system, why are you trusting them to build it in the first place? That just makes no sense to me. And furthermore, it won't help you anyway, because the type of problems that these restrictions tend to avert, like if you don't allow SSH access to your servers, then no one is liable to randomly execute rm-rf on root directory or something. But these problems are getting less and less concerning because we went the route of cloud providers, immutable infrastructure. Infrastructure as code. These types of mistakes are getting harder to make and also easier to recover from. So you're not actually solving a big problem if you do this, but you are creating a big one for your engineers when they're trying to debug the system. So ideally, just don't do that, or when you have to, do it minimally and have an easy way of breaking through those barriers. Number 3, very, very common mistake made by a lot of organizations. Do not think of failures as the exception. Failures are a normal part of the mode of operation for your system. Let us consider this architecture diagram. Obviously not mine. This is from the Slack case study on the AWS website, and it's just an example. The details here really don't matter. What matters is this. whatever stack you build in, whatever cloud provider you use, whatever type of service you build, if it's non-trivial, you're going to end up with your code running on a very, very, very small piece of your architecture. So for instance, in this case, if you are a server engineer writing code for Slack in this case, and you're deploying services, your code runs here, right? This one small piece of the architecture diagram, that's where you run. That's the thing you are immediately responsible for. And what this means is that everything around it is very likely to fail. Things fail all the time these days. You have all these moving pieces in your architecture. You have, at any given point, you're going to have servers that are down. You're going to have network routers that are borked, that are dropping packets or duplicating them all over the place. You're going to have third-party dependencies that are down. You're going to have dead hard drives and servers that are degrading service. All of these things happen literally all the time. So what this means is, as engineers, we can't pretend otherwise. We can't pretend that everything is going to be running fine. We need to design our systems in a way where some part of the system can fail, but the system as a whole keeps on chugging. So if this is your architecture diagram, you should be able to answer questions like, what happens if you lose an RDS instance? Well, sure, you might say we replicate to different availability zones. Well, what happens if you lose an entire availability zone? Well, maybe you are replicated to other regions. Maybe you operate in multiple regions. Well, that's fine. What happens if you lose a third-party service like SQS? Or, in fact, what happens if you lose your entire VPC, right? These things can happen, and you have to have answers. Now, the answers do not have to be state-of-the-art. The answers do not have to be sophisticated. It is a perfectly valid answer to say, if all of these services that we depend on the critical path are down, then we are down. And here's what we do about it, right? If we lose, all our RDS instances or whatnot to a data corruption bug, then we restore from backup, and it means we're going to be unavailable for 6 hours. That's a valid answer. It's not a very sophisticated one. It's not a particularly modern answer. What I'm saying is, you can get away with simple answers. You can't get away by not having them. And crucially, what this means is that if your system, your modern day system that's built with on top of a cloud provider, utilizing various third-party services, utilizing a lot of infrastructure from your platform as a service type provider, a lot of things are going to go wrong. And what this means is, if you want to be ready for them, you need to plan for failure, you need to design for failure, and crucially, you need to drill failure, right? Everybody knows that if you have a database and you back it up and you don't drill backups and restores of your database, then effectively you have no backup at all. You don't really know what's going to happen when things really break, right? It's the same thing with any type of intermittent failure that is likely in your application, including network, third-party, and all of these things. Which, for those of you that have guessed what I'm going to say next, you guessed right, because the discipline that drives this sort of thinking is nowadays called chaos engineering, and chaos engineering is your friend. The mechanics of chaos engineering vary wildly. It's still something that we, as an industry, are developing and learning. But the basic premise is this: if parts of your system are going to fail, and they are, then you should drill for it. You should just take them down and see what happens, and then learn from that, design around it, make your system more and more resilient. And a lot of organizations, including, by the way, a lot of the organizations I'd worked for, failed to appreciate the simple truth and ended up with simple transient failures becoming cascade failures and full-blown production outages. So that is, I feel, a lesson we have yet to learn, although we are definitely making strides as an industry in this space. Next, do not make problems go away. This is super, super, super common and super, super, super insidious. What happens at 3 o'clock in the morning when the system breaks? You have an engineer on call, they're researching the problem, and they just cannot make heads and tails of the problem, right? If you have a service, the service is behaving in some pathological way, it's broken fundamentally, and you don't really know why, you've run out of ideas on what to do with it. Well, what do? Have you tried rebooting it? That's kind of what everyone does, right? Once you've exhausted your set of ideas, you just try rebooting and hope for the best. Now, this in and of itself is not necessarily a bad idea, because rebooting does reset state. It tends to make systems restore their ability to function, at least temporarily. But there are two very, very important ramifications of rebooting any part of a system that you should keep in mind. The first, sort of the axiom driving these, is that reboot is usually the resort of panic. The system is bad, I don't know what to do, I'm going to reboot it. And when I reboot it, two very nasty ramifications happen. The first is you get a bunch of very nasty side effects out of rebooting virtually any part of your system. The most obvious side effects that can happen when rebooting, depending on what you mean by reboot, which part of the system, obviously, but that being said, in general, you can expect 0 or more of the following. 0 if you're lucky, 1 or more if you're a little bit more unlucky. The obvious causes of rebooting a system can be data loss, because if you reboot anything, especially a server, while I/O is still pending, then you might have data that's lost. You can have corrupt data, like corrupt indices for a SQL server of any sort, etc. And obviously, you have transactions that are in flight, like users are actually interacting with your system as you're rebooting it. And those transactions, unless you've designed for it, will be dropped. Okay, so users will be interrupted. These are kind of the obvious side effects. But there are a lot of sort of second-tier effects that are not only a lot more dangerous, but also a lot harder to predict. So this can include things like partial transactions, right? You have some sort of transaction in progress, it is not atomic, and now you have a piece of state that's in sort of in between states. And if you haven't designed for that, then once again, you're going to leave your system in an inconsistent state that may or may not pop up down the road. The crucial thing about these types of failures is that you may not experience them immediately. If you've had the experience of going into a production system, digging into the database and finding data that just flat out doesn't make any sense, like no code path that you can see should lead to the data being in the state that it's in, it might be the result of this. You can also have other subtle issues like data inconsistencies between replicas, between data stores, between data centers, which again will be very hard to detect and will screw you over very badly, anywhere from hours to months down the road. But there are also very technical kind of ramifications. Like, for instance, if you have a service that's providing some sort of service to end users and has a, say, in-memory cache, if you reboot it, when it starts up, presumably it's going to warm up that cache, which will not only mean that all of the load on that server will be distributed among all the other servers, but now as part of that cache warm-up, you're actually creating load on your database while the system as a whole is under load, thereby effectively DOSing your own infrastructure, which is an extremely common failure mode, right? So all of these nasty side effects are things you don't generally think about when it's 3 o'clock in the morning and you're rebooting some part of a system in a panic. The other ugly ramification is that any reboot is effectively a lost opportunity. You have a system that's in a unique bad state. It's unexpected by definition, because if it was expected, you'd have probably designed for it and you wouldn't be waking up at 3 a.m. It's pathological because, again, if the problem isn't severe, you wouldn't be waking up at 3 a.m. And it's visible because if the problem was not experienced by users, again, ideally, you would not be waking up at 3 a.m. for it, right? So you have your system in a unique pathological state that you did not foresee, and it is a golden opportunity to learn about how your system works, what can make it fail, what are its various attributes, And if you reboot, you have lost that opportunity, right? You will never again, you might, but you can't know that you will ever again see the system in that state. And not being able to reason about the state of the system also means that you don't really know what side effects that issue that woke you up at 3 a.m. has. You're not going to know if there's going to be any data corruption or data inconsistency or any one of these things, because quite simply, all of the state of the system is lost to the ether. So before you reboot a system, even if you've considered or not considered all those nasty side effects, what you really should do is you should collect as much evidence as humanly possible before rebooting that part of the system. Collect things like thread dumps, heap dumps, metrics, logs. Just go to Kibana, save the logs for that service from like the half hour around the incident. Just save them aside, export to a CSV, do whatever it is you have to do so that you can later refer back and reason about the issue when the system is back up and running and you're not under fire. And crucially, do that. Act on that data. Document it, open an issue in GitHub, add these attachments, and make sure you circle back to it. Because again, your system is officially in a bad state and you don't know how it got there. And if you don't circle back to it, you will never know how the system got to that state, and you will have that problem forever. If you don't consider these two ramifications, if you reboot willy-nilly, do not consider side effects, do not collect the data, then you are making this guy very, very angry. This is Brian Cantrell. He's the legendary ex-CTO of Joyent, the company previously behind Node and the Joyent Cloud. He's sort of a mythological figure in the industry at this point because of how angry he gets about things. And the way he put it in the talk that is linked below is, if you reboot the system, you have essentially signed a suicide pact. The system will break in wonderful, unexpected ways further down the road because of a problem you had failed to address, right? So just don't. At least collect the evidence so you can know about it. At least collect the thread dumps and the metrics so that next time it happens, you can at least know that it's the same issue and not ignore it again, right? Do something about it. Last but not least, my own personal pet peeve. Do not harass your debuggers. At 3 o'clock at night, when shit hits the fan, when your on-call person, when your on-call engineer is woken up to deal with a problem, they are your first and effectively only line of defense against unavailability. Right there and then, when your production system is down and your on-call engineer is dealing with the problem, theirs is the single most important job in your organization, in your company. Because right there and then, what is clear is that your livelihood is at stake. Your system is down, you cannot conduct business, your reputation suffers, this will have cascading effects down the road, your livelihood is in danger. And the people who are responsible to bring the system back online, to build business continuity, to enable your customers to go back to work and not be pissed off at you, are your on-call engineers. And yet, even though it's 3 o'clock at night, we expect our on-call engineers to not only research the problem, figure out and execute a fix, we're also asking them to provide status updates to stakeholders, including their manager, the CTO, sometimes the CEO of the company. They're generally the people responsible for communicating issues to customers, whether it's through tools like Intercom or status pages, etc. We are basically haranguing them from every direction and causing them to context switch out of whatever it is that they do all the time, when the thing that is most important is to figure out the problem and resolve it. And the end result is this: their heads will explode. What this effectively means is that you are delaying fixing the problem, you are causing the problem to be worse, you are increasing the likelihood of human error while making delicate changes to a running production system under fire, which is insane. Now, what to do about it depends on the type of company you are and the size of the company you are. If you're small, there really isn't that much you can do about it. But usually if you're a small startup and your engineers are doing on-call rotations and providing tech support and all these things, you don't really have much of a choice. But then you also hire people who are capable of doing all these things at the same time. Also, because you're a startup, usually your problems are not going to be quite as subtle. But as you grow, as more and more people use your system, as more and more people rely on your system, as more people are involved in your system, your staff grows, your engineering organization grows, your support grows, all of these things are happening, it becomes harder and harder to practice good on-call etiquette. Because there are multiple stakeholders with multiple perspectives into the problem, and they all care, right? No one does this because they want to bother the engineer that woke up at 3 o'clock in the morning. Everyone does this because they care and because they're worried about the state of affairs in their particular, corner of the organization. So what can you do about it? Really, out of all the companies that I've had any sort of interaction with, the only companies where this isn't a huge problem that I've seen have exactly two things in common. The first thing that all of these companies do is they make explicit and ahead of time all of the ownership, stakeholders, and communication lines around issue management. So basically, they build up an incident management and incident response plan. But more crucially, it is clear ahead of time to everyone that could be involved in dealing with an issue what their function is, what the expectations of them is, and how they communicate with each other, right? It's not this mishmash of, oh, I talked to this engineer about it, but it was over whatever. It was over Google Meet, and there it's Facebook Messenger, instead of doing it over Slack or Intercom or whatever. That salad of tools, that salad of people talking to each other and over each other's head over various tools is incredibly corrosive to your on-duty engineer's state of mind, and it is incredibly bad for your ability to retain availability and restore functionality. Instead, what you should do is you should assign to any issue, there should be an assigned owner explicitly and ahead of time. Like the process by which someone becomes an owner of a production issue should be clear. And usually it's just the on-call engineer responding to the issue. And that person, that's the other thing that those companies do. That person essentially acts like the Capcom, like the capsule communicator. So what this means is, I'll use an analogy from another industry. When NASA sends a rocket ship to the moon, right? What they do is they have all these engineers on the ground that are in the operations center, what you see on TV, and you have the astronauts in space. Now, obviously, I'm not in that space. I can't speak about it very authoritatively, but this is a well-known thing coming out of the Apollo program. Everyone on the ground can talk to each other in whatever way they see fit. All the astronauts in space can talk to each other freely. When cross-communication happens, when any of the astronauts needs to talk to ground control, or vice versa, when ground control needs to instruct or ask anything of the astronauts, all of that communication goes through exactly one person. That is the capsule communicator. That one person is responsible for collating, translating, whatever it is that's necessary, and making sure information comes across consistently. What you get out of that is you have all the constituents that are dealing with any particular, all the stakeholders that are dealing with any particular production issue are always talking to the same person, so they get the same information at the same time, through the same means, in the same voice. And that is super important in averting the sort of mess that you see around production incidents. That averts the necessity of having everyone jump on a call necessarily. That averts these sort of discussions around what's the status on this? I don't know. Ask engineer X. Engineer X says I don't know. Ask engineer Y. All of these problems are solved by having a single issue owner on top of things, and where all communication between this different groups goes through that one issue owner. These two things put together generally tend to either solve the problem or make it minor enough that it doesn't require an organizational solution, and obviously it doesn't bring down your production system, and it doesn't hamper your efforts to bring it back up at 3 a.m. So, quick recap in conclusion. Do not make things impossible to break as a panic reaction. Do not put artificial barriers in place proactively because you think you have to or because you don't trust your engineers. Do not think of failures as exceptional. Failures are the normal mode of operation for your system. You should design and drill for them. Do not make problems go away by rebooting. And if you do, then take all of the things we discussed into account. And do not harass your debuggers while they're trying to bring your system back up while under fire at 3 a.m. Instead, what you should do is you should trust your engineers. They are the ones who have context. They are the people you hire to build and operate the system. You should assume and plan for failure, and you should drill failure. You should gather evidence before acting, particularly in the face of reboot. Even if you don't do anything with that evidence right away, even if you're still going to reboot, make sure you have as much data as possible and set it aside and circle back to it. And invest in proper incident management procedures. Make sure you have explicit lines of communication, explicit ownership of production issues, and that all of the communication between different groups goes through that issue owner and that issue owner only. If you don't do these things and do these things instead, then you won't, live happily ever after, but you are a lot less likely to be unavailable on account of things that you could have foreseen and should not have hampered your efforts in the first place. With that, I'll be happy to take any questions. Thank you very much.
Thank you, Thomas. That was very interesting to go through. So we don't have any questions as yet posted on chat, but I have one on my own. So after going all the do's, communications has been perfect, etc. After everything is fixed, how do we give feedback to the cause of the problem? If it was an engineer, if it was an ops guy, like pointing the finger that it was your fault that this happened.
Well, there's really two parts of the answer I would give to that, I guess. One is, if you're not already, then you should at least consider sort of adopting the concept of blameless post-mortems. Generally speaking, when you have a production outage and when you're doing a post-mortem after that, your goal is not to find who's responsible. Your goal is to find what went wrong organizationally and how to mitigate it or avert it next time. Now, quite frankly, if someone screwed up badly enough that you want to point a finger at them, then that finger should either be a very difficult but necessary conversation on a one-to-one with the engineer, or a pink slip and go home, right? If the blame is bad enough, if someone screwed up badly enough and clearly enough that you feel the need to do something about it, then it becomes a personal, professional matter. Right, starting with performance improvement plans and ending with termination for cause, depending on context. More importantly, though, I think casting blame just misses the point. The point is, how do we make sure we don't screw up in this way again? And part of that is accepting the fact that categorically, some screw-ups are inevitable. Again, you have humans in the mix, and your third-party providers and your cloud providers have humans in the mix. Sooner or later, something is going to go wrong. And what you should, in my opinion, what everyone should be focusing on is not how to prevent things from going wrong. It's how to make it easy and cheap to recover and easy and cheap to learn from it. If you invest in that, then your overall quality over time will improve significantly.
Okay, that makes sense. Thank you once again. Tika says thanks, fantastic on the chat. Yeah.
Right.
So with
Thank you
that,
very much.
yeah. So with that, I have run out of speakers, guys. It's been awesome emceeing this event. Fun. I've learned a lot. I've grown. And I guess I want to hand it over back to Natalie if she is here for the closing
Hi.
session. Hi.
Thank you very much, Tomal, again, and thank you very much, Priscilla, for the emceeing. You've done an awesome job. Whoop, whoop, on behalf of everyone.
Thank
you. Tomer will probably be around to answer some more questions if anybody has after our closing notes, but thanks again.
Thank you.
And I would like to share some numbers with you all. So we have been running this questionnaire or this poll throughout the days of the conference, and we have mostly software engineers on board, like by far mostly software engineers, and then others, and then one of each. So it's cool to see that there's a lot of interest in this. It's a good feedback for us to know that even though people who are not working in this right now are very much interested in this, and that we deal with definitely people who are well experienced. So we learned, and we hope this content was interesting for you. And to summarize this past 2 days that have been rather intense, I would like to start as saying big thank you to our speakers. You all applied in sometime in winter, November, December, maybe beginning of January, thinking you'll be coming to Berlin to give your talk, and then you ended up doing this online from the comfort of your home. Several mentioned that this was the first time that they're doing an online talk, and this was an adventure and experience for everyone, and we hope you had as much fun as we did. Another big thank you to Priscilla and Gira, our MC. Follow her on Twitter. Lots of technical content, more of those interesting conversations that you were hearing, chatting back and forth with our speakers. Another big thank you to our team. Donna, who was behind the stages in the backstage and making sure that everything takes place, and Lito, who was doing a lot of the logistics. And huge thanks to our sponsors. It's not possible to make a conference without sponsors, even if it's online. And we said thank you yesterday, and we're saying thanks again. Go check out the booths in the expo area. Say hi. Awesome companies. And we are going to upload all the recorded talks once they went through post-processing to our YouTube channel. So you're welcome to go and rewatch all the talks that you missed or wasn't sure or wanna look again. Most of the talks will have in the beginning or in the end contact details to the speakers. If it's email, if it's Twitter, so you can always have the conversation ongoing. And we do encourage you that if you do end up watching again or sharing with friends who couldn't attend and inviting them to watch, and then you have questions, make this public. Don't send a DM, ask on Twitter, tag the speaker, and then you're gonna start an interesting conversation. You're welcome to tag us as well if you want. If you've been taking notes and learnings or have interesting pictures and so on, tag us or tweet at us. We will retweet. We're CloudNein_conf, and that's our handle, and the hashtag of the conference is just CloudNein. As you saw, the talks were super fascinating, super interesting. The conversations were really good around it, and the attendance rate is definitely something we aspire to reach same levels as GopherCon. To those who attended last week. And we encourage you to help us spread the word. We would love to host this conference again. We would love to talk more about SRE and more about observability and more about DevOps. This is an interesting topic. This is personally interesting for me. This is obviously interesting for you all because you are here today. help us spread the word. We will meet again next year. And thank you very much again. Please stay to enjoy the networking sessions. You go to the sessions tab, and then there's a coffee corner, which is like a Zoom call. Everybody can join in and open their video and just chit chat. Or you can go to the networking tab in the list on the left, and then you'll be matched with a speaker for 2 minutes 40 of a video call where you get to chat about anything you want. If you need a conversation starter, mention your favorite talk. Something you agreed with, something you disagreed, something that made you think. It's always a good way to speak with somebody. And it's only 2.5 minutes, so it's not too engaging. And with this, thanks again, and hope to see you all next year. Bye.